Josh. Like I said, any questions, please drop them in the chat, and yeah, I'll hand it over to Josh, and we'll get started.
Awesome. Thanks, Wendy. Good morning, good evening, good afternoon, depending on where you're joining us from. I know we are started right at noon here, my time on the East Coast. As people start to trickle in, as Wendy mentioned, I'm going to share my slides. I can't really see you, but please feel free to raise a hand. Wendy will stop me. Jump in with questions, put them in the chat. Wendy will stop me. Like she mentioned, I prefer things to be as interactive as possible. I know that's not always great on a webinar, but yeah, please ask the question. If it's something that is coming up, I'll let you know. Oh, hey, we're going to talk about that in a little bit, or I'll answer the question right away. I have done a lot of presenting in my life, but I'm certainly not perfect, so I certainly want all those questions. And yeah, would gladly take the time. We should actually have some extra time today to be able to chat as well. So I think Wendy just put it down in the chat area for you to be able to put it in. So hopefully everyone can see my slides. Wendy, yes, we good?
Yep, looking good.
Awesome. So today we're going to talk about life cycle assessments, sometimes life cycle analysis called LCAs, and EPDs, environmental product declarations. My name is Josh Jacobs. I'm Managing Director of Buildings and Policy here at WAP Sustainability. We're the largest LCA provider in North America, and we have a global basis where we do LCAs around the world. I've been working in this type of community for about 17 years now. WAP has also been around for 17 years. I was proud to be a part and help with some presentations in the original UK Supply Chain Sustainability School that's still going strong as well. So these are things that Wendy asks me to say. Camera and microphones off just due to our other audience and trying to be respectful of them. Thank you. Again, if and when I ask a question, jump in or you jump in, please. Drop your Q&A in the boxes or questions. Share your feedback at the end, as Wendy mentioned, and slides and recordings will be coming afterwards. So you're more than welcome to them. Again, we're going to go over what the heck. I'm going to introduce you to this LCA and some of the other acronyms we like to use. In sustainability, we love our acronyms. I may make up 3 just as we talk here. So got to decode what the heck all that means. Going to talk to you about how do we do an LCA? How do you get started? What is the process of that? And then why the heck is this LCA thing important, right? And we'll talk obviously about the environmental product declaration and the different ways that that's getting used specifically here in North America at the moment. So let's talk about this life cycle assessment. Want to talk about the acronyms first. And again, some of them I've already started to use. Life cycle assessment, or LCA, is an assessment of the environmental impacts associated with producing a product, with using a product, with the end of life of product. And they're in accordance with an ISO standard called 14040 and ISO 14044. These govern how we do life cycle assessment for all types of products. I've also used the terminology EPD, or Environmental Product Declaration. This is a summary document of the life cycle assessment. We'll get into why you would have a summary document here in a couple slides. But these are based off of ISO 14025. As you can tell, we have a lot of governance of these standards. I actually was a part of the most recent rewrite of ISO 14025. Colleagues of mine have been involved with the 14040 and 44 processes over the years. We're very proud to be involved in the actual development of these guidance standards that are out here for this. You also have something called product category rule. So product category rules are basically specific sets of rules for conducting, how to do an LCA to get it to an environmental product declaration. So you actually see over here on the right-hand side that you kind of start with a product category rule for a specific type of product, like say steel, or a specific product category for gypsum board, or for flooring, or for furnishings. And you start with that because it sort of tells you what you need to gather in the LCA and how to talk. Then you do the life cycle assessment based on 1440, and that produces an environmental product declaration. That is then verified by a PO, or a program operator. Obviously, PO has been known lots of different things, but program operator is how we refer to it here. It's a third party that actually conducts an environmental product declaration program. and they actually verify that what is in the EPD was actually come out of the data that comes out of an LCA per the product category rules. So now that I've thrown a million acronyms at you, there won't be a quiz or a test. But again, just want to kind of give you the lay of the land where we are. So what the heck is a life cycle assessment? It's exactly what it sounds like. It is an assessment of the entire life cycle of a product. So almost every product known to man that has ever been made is something that comes from raw materials or recycled content per se. Hopefully we'll get into that a little bit here, but hopefully we're doing a lot of recycling of material, but it comes from raw materials that have to get to out of the ground sometimes, or again, from old used products that are grind up to get us new products. And then it's sent to a manufacturing facility. The manufacturing facility takes those components, obviously uses electricity and water and some other things while it's creating this new product. Once that product is created, it goes to packaging. That packaging goes to distribution. That distribution, then the product gets used out in the world. And then you have an end of life. And hopefully it doesn't just get thrown away. Hopefully it becomes some form of recycled content, right? It's taken apart. There are parts reused. It's ground up. There's lots of different things. So again, what we're hopeful here is that it truly becomes a circular program, right? Where products are being made is also taken apart and either turned into something else or used to create new kinds of that same product. But the life cycle assessment goes into each of these, gathers data, and puts it together to understand the entire impact. So literally taking information about the raw materials, taking information about the packaging. How does the product get used? Does it require energy? Most building products obviously don't require energy in their use phase, but something like flooring has to be cleaned typically. Well, then there's a use phase energy, in fact, for choosing different types of flooring and things of that nature. And then the end of life, right? Certain products are mostly, 90+% of it is thrown out because it's so readily available to us humans, we throw it out. But then there's other things like steel, for example, which like most steel on the planet is not virgin steel. It's recycled steel. We've been doing it. We do it very well. We've been doing it for a very long time. It's also financially feasible. So again, that recycled content is very, very high in most of the building material steel that we use. So the LCA is quantifying all of those different environmental impacts. We'll actually go over the individual LCA impacts that are out there and come out in a life cycle assessment report. And they're about over that entire life cycle. Again, when I talk about life cycle in a slide here, I'm going to talk about the actual individual stages that we talk about in a life cycle. But if you look at this photo here on the left-hand side of the slide, it really details the individual areas that we have. When I try to explain it in just general terms, I always talk about the plastic and the paper bag. I know growing up, this was a very big deal, right? And people talked about paper versus plastic. Even today, lots of the big grocery stores have individual bags that they'll sell you that are sturdier and things of that nature, typically made out of recycled plastic. There are entire states in the United States and municipalities in Canada that will charge you. Now, they have to charge you for a plastic bag, or you have to bring your own because they are not allowed to just give out plastic bags due to certain individual authority having jurisdiction laws. The interesting thing, though, is the best way I can explain what a life cycle assessment can do is it can truly answer that question for us, which is better for the environment, a plastic bag or a paper bag? Now, this is when people sort of perk up and they go, oh, I'm finally going to get the answer. The problem is the answer is always, it depends. And that's because when we do life cycle assessments, it's an incredibly iterative process. We go back and forth with lots of questions. So like with paper and plastic, the question is, how heavy are the groceries you're carrying? Are you going to reuse the plastic bag multiple times back at home? Are you carrying like a gallon of milk that's, it's not only heavy, but it's a warm day out, it's cold milk, and now it's sweating and the bag is starting to deteriorate and you've got to walk a couple blocks to your house. So again, there's lots of variables that dictate which one would be better for the situation specifically that we're talking about and what you're carrying and what you're taking back. But life cycle assessment can tell us which one would be better for us long term. Does the paper bag come from sustainably harvested forests, or is it virgin timber that just doesn't get regrown and that's it? So again, these are things we can sit and talk about and understand, put them into a life cycle assessment model, and truly be able to compare and contrast the individual impacts that each product has. So I was talking about the boundaries around life cycle assessment and the stages in life cycle assessment. We do have different boundaries that we need to talk about. This entire thing is typically called cradle to grave. Literally all the way on the left-hand side, you see the extraction of raw materials that are coming out of the ground, all the way through the use phase, to the end of life, to this recovery and reuse potential in what's column D over there. So these life cycle stages are broken down. Most of today's life cycle assessments that go into, specifically the ones that go into environmental product declarations, are typically done to cradle to what's called gate. This is our first gate because this is our gate where it's leaving our facility that we manufacture a product in. So literally cradle meaning we're taking it out of the ground as a baby. We're transporting all of that material to a manufacturing facility. We're making the product, and then we're shipping it out of our facility, that last gate, right? We're putting it on a truck and it gets transported to a site. It gets put into a building in some form or fashion, and it gets used in that end of life. So again, most life cycle assessments, or EPDs, you're going to see are going to state what life cycle stage they're from, or they have to state that. Not most, they are going to have to state that, but most of them are going to be on that cradle to gate level. This is what they talk about. There are actually gate to gate LCAs that are done like, hey, we just want to focus on our factory inputs and what's happening. That is much, much rarer. I will say, though, that more and more products are starting to move to cradle to grave for their life cycle assessments. This is because when we originally started out in life cycle assessments and specifically asking for environmental product declarations, cradle to gate was information we could get, right? We could understand, okay, what the heck the product's made of. We could understand how we're getting those raw materials or recycled material into our facilities. We could understand how much energy and water and waste that our manufacturing facilities had. Everything else was a little bit foreign. Obviously, use phase with certain products, if there's actual energy use or water use of the product when it's used. End of life was almost completely foreign to most. So we really focused on the cradle to gate when we developed the original lead language around environmental product declarations. We focused on this cradle to gate because we knew manufacturers could get this information. We knew that they could produce this in a life cycle assessment. Now, again, more and more products are moving across us. Certainly products like my laptop that I'm presenting on today, we have to include the use phase in that because it's a plastic and metal brick if it doesn't use energy, right? So a huge part of the life cycle impact on the environment for my laptop comes from the energy used in use, right? So we have to include that there. Again, there's a lot of work being done on the construction of buildings and how much energy actually is used to install products. Again, the end of life is a huge focus area as well. How are buildings being taken apart? Are they just being demolished and thrown away? Or are we doing recycling and deconstruction processes and things of that nature? So again, these are some of the terminology we use when we're boundary setting around a life cycle assessment. But again, this is the most common today, the cradle to gate, but you are seeing more cradle to grave life cycle assessments. So what are some of these outputs of life cycle assessments? We have lots of different information that can come out of a life cycle assessment. You see some here on the left: global warming potential, acidification potential, eutrophication potential, which is like acid rain into, again, lakes and stuff, which was big here in North America when I was growing up. Smog formation potential. Obviously, if back in the day, if you were flying into, say, Houston or Los Angeles, you flew through smog. Ozone depletion potential. Obviously, we've all heard about the ozone layer, which we've done much better in reducing our impact on that. Blue water consumption, fossil resource depletion, both abiotic and mineral resource depletion is a part of that. These are all things that can be calculated in a life cycle assessment. They tell a fully holistic story beyond just carbon emissions. I will tell you that, oops, sorry, you have to hit the button. I will tell you that the number one thing that is looked for today out of all of this is the global warming potential, the GWP. And that's typically, it's expressed as kilograms per CO2 equivalent. We know how to calculate carbon dioxide. It's a well-known commodity or language that people speak. So that's why that is the unit of measure that's used. So if someone's talking about embodied carbon, if someone's talking about a carbon footprint, if someone's talking about, hey, I need to know your impacts for my scope 3, which we'll get into in a number of slides here, they're asking for your GWP. They're specifically asking about that global warming potential. Product carbon footprint is a little bit different. It specifically focuses just on carbon, but that GWP number is really important in overall calculations of that embodied impact information. Again, it is not to minimize all of the other impact areas. There are things where something can be reducing its global warming potential, and ozone depletion or eutrophication potential is much higher than we want it to be. But as of right now, global warming potential, specifically here in North America, is the area that is really, really, really focused on. We'll get into a couple of the areas and how it's really focused on in a number of slides here. So again, those are the categories that are coming out, and you see some of them listed here on the bottom of this slide. Again, the climate change is that kilograms per CO2 equivalent, specifically the global warming potential. The interesting part of this, though, is a life cycle assessment. There's a lot of the data shared like this inside a life cycle assessment report, which, by the way, life cycle assessment reports are typically 120, 130 pages long. These are very detailed reports, lots of proprietary information in them, which is typically why we go to an environmental product declaration when you're wanting to share it. But a lot of the data is shared in tables like this. What it's doing, though, is when we do a life cycle assessment, we're able to sort of do hot spotting, right? We're able to look and understand where are the trade-offs in what we're doing. Over here, you see where, the raw materials of a product isn't very big of an impact in here, right? Typically for a building material, the raw materials is your largest impact area. It's where you're going to be able to do the most reductions, is by minimizing the impact of your raw materials. Here, the largest impact area is the use phase in all of these categories for this product. If I remember correctly, when we took this slide and took this specific count out, I believe this is actually for a computer. And as you can see, the use phase is far and away number one, right? The use phase for global warming potential, the EF 3.0, climate change, the kilograms per CO2 equivalent all the way to the left, is over 80%, right? Over 80% of the impact comes from its use phase of life. Well, that makes sense, right? It's made of, my laptop is made of plastics, has some metal in it, which the metal can do some impacts. Plastics also have some impact area. But again, the raw material transporting and the electricity and water used to create the product is very minimal. But when I have to plug it in every day and use it, that is where the large impact area comes. But again, you're able to look here and be like, okay, if we want to reduce our impact of our product, we try and make it use less energy, right? Obviously, if we're looking at acidification potential, maybe we start to look at some of our raw materials here and make some reductions, because that's starting to trend towards 30% of the impact area. But again, this data can really help you not only communicate your impacts, but it can help organizations make better decisions internally. Most people, we've done tens of thousands of LCAs now. Most organizations, manufacturers, when they come to us, they're like, hey, someone's asked me for an LCA or an EPD. I need to do this life cycle assessment to check a box or to sell a product, get that return on investment. And don't get me wrong, that is incredibly important. Certainly something that needs to happen. However someone starts to look at their environmental impact is great. But I would say 80+% of our manufacturers that we end up working with end up finding out data or information that they just might not have known. Like, why do I have these two suppliers of the same exact material at two different factories, but one has a much less environmental impact than the other? Well, depending on how the product is made, that can really be much less. So again, you want to make sure that you're looking at that and making good decisions based on data. Wendy, I've been talking a while. Are there any questions yet?
No questions yet. No, I'll try to interrupt if we get one through.
Awesome. And remember, folks, if you've just joined, please ask questions as I'm going. I'm a Northeastern United States kid from Boston. I will talk till the cows come home. There's no real train of thought. It's sort of a scattering, so you're not going to interrupt the flow or anything like that. So please jump in and ask your questions. More than willing. If you've got that question, I can almost guarantee a lot of other people do as well. So again, this is more of that interpretation, trying to understand how you make decisions. Again, when you make material changes, right? You want to understand what those are going to do to your products. We do what are called R&D, or back of the napkin life cycle assessments, where organizations are making decisions and they're trying to replace from one to the other. An interesting specific example is we had a company that we worked with a number of years ago that was had made a decision, because plastics were very big in the news at that time, that plastics were bad and were harming the environment and doing potentially harmful things. So this organization said, okay, we're going to go away from our plastic packaging. We're going to go to a bio-based packaging. We're going to go to more cardboard type packaging. And they thought that's a very good move, publicity wise, marketing wise, because plastics is bad, right? That's how it was stated. Please understand, I'm not stating that. That was their reasoning for why they did this change. And as you can see, the results down here in the right-hand side, you'll see that the old packaging was only around 500 grams. Their new packaging, to protect the product and do what it needed to do to be shipped, was about 750 grams total, right? Well, they wanted to understand that overall impact. The engineers said, hey, yeah, great, marketing's driving this and we want this done. But we were doing life cycle assessments for their products. So they said, hey, can we understand what our packaging's doing? We made this change. You see the results up in the upper left-hand corner as well down here on the right. Their old packaging, their number for global warming potential, excluding biogenic carbon, for their old packaging was right around 1.3 kilograms per CO2 equivalent. Their new packaging, however, was above 1.4 and approaching 1.5 kilograms per CO2 equivalent. So the issue there was they made this change to be more environmentally friendly. But the problem was, when you truly looked at the two packages on an overall environmental impact area, you had a much greater impact with the new packaging. Now, you see over here where it says GWP, including biogenic carbon, obviously things that are made of wood or other plant-based material do take in carbon. There is lots of discussion in the life cycle assessment world around biogenic carbon, how to do the calculation, how to include it, when to include it. I know when WAP typically does life cycle assessments that can or can't include biogenic carbon, we typically list both numbers, because organizations in the outside world, they will have to decide how they're doing the calculation. Are they calculating it with the biogenic carbon calculated and that holding, or are they doing it without? Again, those numbers look a little bit different depending on if that packaging is going to last forever and the carbon is going to be sequestered in that packaging, or like the results in the middle that we see that the new packaging was a higher impact area. But again, the point stands that they made a decision without having all the information. They made a decision simply based on a messaging concept. which that's fine if that still works out for them. But when you're looking, you need as much data when you're starting to make choices, and life cycle assessment can give you that. So that's kind of what the heck an LCA is. We're going to get into developing an LCA. So again, if there's any questions, standalone questions on kind of what that is, I'll give you a chance here now to ask them. And then we'll get into specifically, hey, how the heck are we putting an LCA together?
Yeah, so no questions in the chat, but I'm going to drop a couple of questions in the chat for you guys to just have a think, maybe spark some discussion. So I think we'll press on, and yeah, would love to get some questions or comments from the audience.
Awesome. Thanks, Wendy. So as I mentioned, LCA is an incredibly iterative process. It is a constant asking questions, developing models, getting data, going back, asking questions, and going on. This is why a life cycle assessment can take a decent amount of time. The first step in any life cycle assessment is data collection. I'll get into a couple slides here. I'll get into specifically what data needs to be collected. But as anyone who works in manufacturing knows, which would shock the outside world, it doesn't shock all of us who deal with it almost every single day. But it's not always the most common thing to fully understand every single piece of your product, right? If you ask an organization for a BOM, a bill of materials, or a bill of goods on what's in your product, there's not typically one person that has it all or has all the information. So getting all your supplier data and understanding who your suppliers are, where they're coming from, how it's getting there can be incredibly difficult. Also, understanding facility data, getting much easier, much better, much more clarity in this area. But understanding 12 months of electricity used and water used and waste and local effluents coming out of the building can be a difficult thing if an organization's not already tracking it for different legal reasons, meaning complying with local laws and different things like that. Getting that data can be really tough. I'll give you an example. We are working currently with a mechanical equipment manufacturer, and they sent us a BOM the other day of 1,000 lines, literally an Excel spreadsheet with 1,000 lines on it. Now, some of those were right-hand screw, left-hand screw, which were the same exact screw, just, built for one side of a panel versus another side of the panel. So there's some overlap. But even if you're at 50% overlap, which it wasn't, you're still talking 500 individual components for a piece of a mechanical equipment. That is a massive amount of data to collect. So that's the largest amount of time typically taken in a life cycle assessment, is gathering this data, right? What ends up happening is we gather that data. While we're doing that, we're creating the life cycle assessment model by literally talking to the people that make the product, right? How is this product made? How is it put together? We're looking at CAD and design drawings of how the product is made, how it's used, all of that information. We're then putting that data into the life cycle assessment model. We're then getting results out of that, but sometimes those results run and we're like, those are wildly off from what we typically see for a product that's mostly made of aluminum or mostly made of steel or mostly made of a bio-based product. So that's when we go back and we say, hey, did someone give us this data incorrectly? Did someone, accidentally type something in with an extra zero or something like that? We're always wanting to make sure we understand. And sometimes it's much lower and we're like, hey, what new processes are you using to do this really cool thing? Why your life cycle assessment practitioner typically will sign as many NDAs as possible if they're not working directly within your organization, because there's a lot of really cool information to learn to truly do this modeling correctly. The other thing about data collection is again, we typically end up working with a lot of accounting teams because they have to pay the bills, right? So anyone who has to pay the bills really tracks things really well. So they'll typically be able to give us a lot of the data that we need out of information. Wendy, I just saw you pop up, so hopefully that means there's a question.
There is a question, in fact. So we've got a question here from Russ, who asks, how comfortable are you with the non-GWP calculations? GWP inputs are pretty thorough, but with things like eutrophication use defaults, how much effort should be put into digging into this data?
Yeah, so Russ, really good question. GWP is probably our most specific output number because most of the work has been done on that over the years. Some of the others aren't as accurate as we would like. Life cycle assessment also has a number of you have to use some surrogates sometimes. You don't always have all the primary data. Like everyone doesn't know the exact copper supplier that they sometimes have for their products, right? Sometimes they have a copper, supplier that they're getting from a dealer, right? And they're buying it through a group purchasing or something like that. And they don't know the exact mine it's coming from. So we have to utilize industry-wide data for a region. We have these databases that we use for different data. So again, yes, global warming is our most specific number. Some of the other ones are in the ballpark. I'm feeling better and better every day about how much more accurate every single one of these numbers is getting because more and more and more and more of the supply chain is getting filled in because the primary end users, the people who are building buildings, for example, are asking for EPDs. Well, the primary suppliers that they're going to are now asking their suppliers for EPDs and LCA because the more primary data you have, typically the better your numbers look in GWP and in other things because a lot of these background data sets are estimated high for the simple reason that LCA practitioners and sustainability people, we'd rather make sure we're over-counting things than under-counting, right? We're a very cautious bunch. We want to make sure that, hey, decisions are being made based on, this could be painful in an environmental sense. So let's try and reduce as much as we can. Most of the time, the more primary data you get, the better it is. And more of that is happening in the marketplace. That looks like it opened the floodgates, Wendy. I saw things pop up here. There.
We do have another question, and this is actually
Awesome.
something that I am curious about as well. So, can the LCA be done for all product lines as a whole, or can it be done, does it need to be done separately? So LCA per item.
Yeah. So it's an interesting concept. I know many different LCA practitioners work very many different ways. But I know in our world, we try to group things into product categories, right? So that's that product category rule concept. We try and create like what's called a parent life cycle assessment, right? That's where, okay, if you've got like 7 SKUs of the same product, but they have a little bit different, I'm going to use the chair I'm sitting in, right? The chair has different thicknesses of padding and maybe different arms and different casters, but it's the same chair. It's made in the same facility. It's the same area. We do one parent life cycle assessment. And then what we start to do is we do SKU level LCAs where we're saying, oh, this one could have these arms, or this one could have this padding, or it could have these types of casters. And the mix and match then allows us to develop all those other SKUs, right? So again, I would never suggest to do an LCA per SKU level of thing if they're all in the same family. You should be having the same facility level data if they're all made in the same facility. You've got the 12 months of electricity, the 12 months of water, the waste, all that information. So you'll have one there. And then again, what you're doing is you're creating that overarching model, and then you're doing mini fix outs or pop outs on a SKU level change, right? So again, that life cycle assessment allows you to kind of flip things in and out and do minor changes to give you the overall impact of a number of different SKUs.
Awesome. Thanks, Josh.
Yeah, not a problem. Cool. So we were here, and all this is right in here, right? Because this is all happening as we go. We're doing that LCA modeling. We're talking about, oh, do we have multiple different facilities that we need to look at? Oh, do we have a different SKUs? Like things like people are typically like, oh, I'm buying the black one versus I'm buying the red one. And it's like, actually coloring doesn't matter. It's a very small percentage of the overall weight and impact. So like color doesn't matter, but the thickness of the pad on my chair here matters a lot because there's a lot of impact in the padding. Once we get all that done, we get the reporting. Once we do the reporting and we feel comfortable with what we got there, we send it to an external review typically. If you're just doing an LCA, that can be done by someone else internally that hasn't touched it. They're just checking the math, checking all the assumptions that are made. Again, there are times that we'll go back and we'll make sure everything's still all right. Again, that iterative process. But then we want to publish, right? Now, that external review, if it's going to be an environmental product declaration, is going to be done by a program operator, and that publication will be an EPD. Typically, as I mentioned, a life cycle assessment is not handed out to the wide public. The reason being is 130 pages. Most of the public doesn't want to read 130 pages of anything, never mind a life cycle assessment report on your product. Additionally, there's lots of proprietary information. Your secret sauce is in there. It tells you who your suppliers are, talks about your facilities, talks about how the product's made, all the impacts and things of that nature. You don't want to hand that out to the wide world. I don't care how many NDAs you have with individual buyers. That could make its way around. So that's typically why this external review and publication of an LCA, specifically in the building product world, is an environmental product declaration. So the data collection or the recipe for a product, as I mentioned, is ingredients, right? We need to understand supplier data, right? We want raw materials. We want that upstream material production. We would like as much of it to be primary data as possible, right? Tell us who your supplier was, where they're from, because they may have an LCA, they may have an EPD. We want to get as much of that data as possible. We then want to understand how all that is put together, right? The formulation of the product, the individual components and things of that nature, and the manufacturing process. We need to understand the 12 months of electricity and the 12 months of water. And I am saying 12 months because that's what's dictated to us in ISO. There are times when we're allowed to use much less. Like again, in R&D LCA, you don't really know. You're taking a guesstimate. There are products that like, hey, we've been out for 2 or 3 months. Can we use that data and extrapolate? Certainly. We want to be able to use what data we have. We just have to justify it longer term. And then what that does is it produces that final product, that baked good. Who else is hungry for a cupcake? Now that I've thrown that up on screen. So again, this is what we're doing. We're taking those raw materials, we're taking that manufacturing information, we're putting it together, and we're producing that final product and its impacts. The same way a product's made, that's what we're following with life cycle assessments. Now, here is some of the specific data that we need to be collected, right? We need to understand, how much recycled content do you have in your product? We want to understand the type of manufacturing, any material loss during manufacturing. Where are you sourcing your goods, right? How much inbound transportation? How far are things coming to get to you when you're getting the material? What's the material full composition? Specific supplier data, as I mentioned, specific supplier data is incredibly important. The more of that primary data we get, the better most of the time your environmental impact is going to look, as opposed to having to use surrogate data or background data sets just from some of the individual databases that we utilize. Then in the manufacturing requirements, we're going to need to understand what is the energy used over 12 months in your facility. Again, what's the material loss at your facility? What's the water consumption? What's the waste? What's the effluents into the air and water? And then how are we allocating this? How do you sell it? Is it by mass? Is it by unit? Is it hour of labor? How are we dividing all this? Because this becomes a math problem, right? We want to understand your total creation of products from this facility. But if we're only doing an LCA on a little bit, so say you have 1,000 kilowatt hours in 1 year of electricity is used. You're going to have a lot more, but let's just go with me. 1,000 kilowatt hours per year used, but 10% of your products are what we're looking at in LCA. This one product, you make 10% of all your products shipped come from there. So that's where the math we're starting with is 10%. We, of course, have conversations. Oh, is this an manufacturing intense process? Does it take longer than other things, therefore using more water, more energy? In an ideal world, every line that things are made of would be metered individually. 99.9% of the planet does not have individually metered lines, and they don't track the energy and water and waste lost on those individual lines as much as they would like to. It starts to become financially unfeasible. Could we get there someday? Sure, we could, but we're not there right now. So this is sort of a math problem that we work on here. All right, so, Wendy, I see you pop up again. That means there's a question.
That means there's a question. Yes, I do have another question. I believe it's, can a company develop an LCA without a PO? I'm assuming that means purchase order.
A program operator.
Program
Right.
operator.
So
Okay,
yeah,
yeah,
PO.
thank
We
you.
use
Yeah.
PO for lots of things, though. But without a program operator, yes, 1,000%. A program operator is only used when you're going to the EPD. So let me go back really quick, and I'll show it again. So Again, a program operator is only going to be the person verifying the EPD. I have a slide coming up that's going to talk a little more about this, but a life cycle assessment can be done simply on its own. Your life cycle assessment, either internally by someone in your organization, by an external organization like WAP and others that can do the life cycle assessment for you and take you through it and do that. But then at that point, you just have the life cycle assessment. That means if someone's asking for your impacts, you're probably going to have to give them that full life cycle assessment. And that is where all your secret sauce is. So most of the time, people are publishing that EPD through a program operator.
Okay,
What else
great.
you got?
Thanks. We've got one last question here. They say it might be a dumb question. I don't think it's a dumb question at all.
Oh,
But planned obsolescence, how does that fit into an LCA or an EPD? What if the intention is that the product is only in use for X amount of time? I think that's a great question.
yeah, not a dumb question at all. First off, I don't mean to sound like a cat poster hanging on the wall saying hang in there. No such thing as a dumb question, especially if you're just learning this. That's the only way we learn is we ask questions. So please continue to ask any question, not dumb. Then what gets taken into account is the entire material is thrown away. And if you're doing a cradle to grave life cycle assessment, that's going to impact the environmental impact of your product. Right now, if there is if it's only cradle to gate, then the impact stops here. It's not going to be measured that way. But as I mentioned, most products are now starting to look. So if it's planned obsolescence, like, hey, we just throw the product away, then that gets counted, right? It literally gets counted over here in C4, which means that's a negative, right? It's going to, by negative, I mean there's a higher number in C4 because you're not recycling the products or the components of that product. So therefore, your disposal number goes up. Therefore, individual GWP and other impact areas would go up. So it's counted. And same the other way, right? If you have a product that is built to be recycled, you have a take back program, you're getting 50% of the product back, great. That's going to be helpful in your numbers because your numbers are going to look better because you're getting more of that. It's also going to help in the front end because recycled content is much lower impact. Typically a decent impact in the actual manufacturing process, but a much lower impact when it comes to raw material input because it's recycled. So a product sustainability life cycle is we want to know what the heck's going on. Typically that's used to disclose to the outside world. I mentioned this when I was talking about return on investment. People are like, hey, I just got to check a box for a lead point. Or my largest customer, XYZ University, buys a bunch of my products and they say I need an EPD. Great. I got to do an LCA. I got to disclose that. But then all of a sudden, I'm starting to look at the data. Well, what happens when you look at the data is now you're able to start making better products because you're literally doing hot spotting, right? And hopefully your LCA practitioner, if they're good, they'll be able to walk you through this and say, hey, this number is higher than we typically see, specifically with something like metals. There are different ways of making metals nowadays, of smelting things and things of that nature. We're seeing, example, 40 to 60% difference between different types of steel making here around the world now. Massive differences in embodied impacts based on how those are made. What that allows you to do is make better choices and make your product better based on the results. And typically, if you're using two of the same supplier and their pricings are similar, why not choose the one that's a lower impact? It's going to make you look better to these people that are asking for your data. Again, that optimization is how to use your manufacturing energy and water better. How do you lightweight a product? Is there designing for circularity so we're not designing obsolete products? Do we use more recycled content? The original raw materials going in, how do we do that? And are there refurbishment opportunities and concepts that we can bring in? Again, this is always getting better over time. We're getting more precise as we go. We're identifying data requirements in that initial LCA. We don't have all the data. How do we get better data from our systems? As you folks ask your suppliers for LCAs and EPDs, hey, we've seen major building manufacturers start to ask their suppliers for LCAs and EPDs, again, because it lowers their impacts, because they're making better choices, they're making better decisions. So as that starts to get pushed back, we're starting to make better procurement decisions based on optimized impacts, right? So you get more data, you make better choices, therefore your end users, your customers can make better choices as well. So we hope you've understood the key terminology in LCAs. The reasons and drivers I'm going to get to, we did the guides to the steps and creation of an LCA and EPD, but this second bullet is really where people kind of focus on, right? Like, why the heck am I, sorry, click the button again. Why the heck am I doing this, right? And one of the foundational areas I mentioned was an EPD. Again, an environmental product declaration. It is verified by a program operator, an EPD program operator. Again, where that is focused is to get the information out, like your GWP, like your acidification potential, like your eutrophication potential, but do it without giving away your secret sauce, right? So these are being used nowadays as certain municipalities, authorities having jurisdictions, certain architects, designers, engineers are setting global warming potential maximums, which we're going to talk about in a couple slides here. And they're comparing individual products and saying, hey, this product versus this product, this one has a lower GWP, right? And they're doing that through environmental product declarations. To get an EPD, you need a life cycle assessment. It needs to be conducted according to a product category rule, and it needs to be third-party verified by a program operator. Now, there are product categories that do not have product category rules specifically for them. An example is some of these mechanical equipment that I was talking about earlier. Some of these HVAC systems that sit on our roofs and different things like that, air handling units and things of this. They don't have PCRs currently. But thankfully, we have two grandmothers of all product category rules for building products. ISO 21930 is the grandmother of all building material product category rules that tell us how to do that, specifically utilized mostly here in North America and some other areas around the world. And then EN 15804 plus A2 is the EU version. It's the grandmother of all product category rules for building material in the EU, also utilized here and there around the world. They tell us what we need to have for all building material, and then any assumptions that are made by the life cycle assessment practitioner and the organization have to be spelled out in the LCA and finally in the EPD so that people can start to understand what some of those assumptions were done. So again, the creation of an EPD is an incredible, it's one of the number one ways that life cycle assessments are being used. LCAs are being done. Obviously, all that work at manufacturers is also being done, but LCAs have to be done to create an environmental product declaration. With this, your impacts are listed, but not all your secrets. So let's talk about where LCAs and EPDs are getting used. An LCA, what it does for you guys, again, as we talked about, it gives you those environmental hotspots. Where can you start to look and make differences? It can help you report your own Scope 3 greenhouse gas emissions, right? So if your organization is going through the development of greenhouse gas accounting or setting a science-based target, you need to understand your Scope 3 emissions. Well, what you're buying from your suppliers is a large part of that. How are you benchmarking your products against competitors? What suppliers are you looking to reduce their impacts? Can you create a carbon neutral product, right? And then, as I mentioned, science-based targets down here at the end. What it can't do is it's not going to provide your greenhouse gas accounting for you. Scope 1 and 2 are energy utilized at your facilities and any fuel that you're burning on site. The EPD, LCAs and EPDs have nothing to do with that. It can help you a little with Scope 3s, but not all Scope 3 categories. It's not going to help you. It's not going to be an environmental social governance report or an ESG report or even an annual sustainability report. It's going to be specifically about a product. A life cycle assessment is on a product, right? All these other things, greenhouse gas accounting, ESG reporting, these are more for your organization in total. It's also not going to meet any material health or material disclosure requirements along the lines of some of the extended producer responsibility requirements are starting to include LCA requirements. But like if it says, hey, you can't have any PFAS in your product, LCA isn't specifically going to be the thing that tells you whether that is being done or not. Again, it is being used as a design tool, right? I mentioned a lot of this iterative process where people are, doing the LCA, they're coming up with their own internal baselines, they're redesigning a product, they're making progress, and they're going back and they're using LCAs on a consistent basis. We have organizations we work with that are doing LCAs literally annually for the same exact product because they're changing things all the time and they're wanting to get better and better and lower impact areas. So we find it to be an incredibly valuable tool in the design process and redesign process of products. It's also helping meet some of the requirements in the marketplace. There's two individual things that are talking about in the marketplace. There are consumer demands, right? And then there are regulations. So the carrot and the stick, right? On the consumer side, many large organizations are now asking for an EPD or an LCA to meet certain criteria. I know a lot of the major tech firms, for example, are asking for these requirements for many products in their data centers now. Some are asking for a carbon disclosure project, which is more of a corporate level thing. But again, your products play into your corporate carbon number. MEP 2040, I'm a steering committee member of MEP 2040. It's a group of engineers looking to ask mechanical, electrical, and plumbing equipment for more embodied carbon impacts. Then there are regulations, things like Buy Clean Acts. Buy Clean California Act was the first one here in North America. There's also the law AB 2446, which requires all built environment in the coming years in California to have an embodied carbon of that built environment. Therefore, EPDs are going to be necessary there. And then in Europe, you have the CBAM, Carbon Border Adjustment Mechanism, which is a fancy word for carbon tax. They're starting to require that information for people importing materials, certain types of material into the EU, and the Corporate Sustainable Reporting Directive is also in the EU, where they're starting basically to ask for environmental impacts for certain types of products. LCA can also help be meeting certain certifications. I mentioned LEED already. There's also GSEED and BREEAM, Living Product Challenge for the Living Building Challenge program. There's also the Cradle to Cradle certification program, which has LCA requirements in it. If you're looking to get your product climate neutral certified or meet the climate pledge from someone like Amazon or Walmart has their own programs where they're talking about having products with lower impacts that they're going to put through their systems. Again, LCA results help give that data necessary to meet these individual requirements that are out there. LCA, as I mentioned, also can help you be a carbon measurement tool for certain parts. Again, completely different session that is on the Supply Chain Sustainability School on greenhouse gas accounting and corporate reporting and things of that nature. Scope 1 and 2, this isn't helping with, but life cycle assessment can help you in some of the 15 categories that are in greenhouse gas scope 3. So again, your supply chain, purchase goods and services, for example, and then end of life treatment of your sold products, some of your transportation and distribution and things of that nature. Again, these are sorts of areas that your LCA can start to fit into some of this greenhouse gas accounting that you might be doing. It's also a wonderful marketing tool. An LCA or an EPD helps meet customer requests, right? It helps prove you're not greenwashing. We're doing the work to understand our impacts, and here they are, right? Verified by an independent third party. EPDs are. LCA can also be independently verified. But it backs up your claims. You also can do something called a comparative life cycle assessment, where you're comparing an older product of yours or a standard industry generalized product versus your product. You do that comparative LCA, you do one on the new product and the old product, or the existing marketplace product and your product. You do that comparative LCA, it has to run through a three-person panel critical review board. But then that meets the requirements for things like the Federal Trade Commission for saying, hey, we're 10% better than we were last year, or something like that. Again, LCA as a compliance tool. Again, this is LCA typically going into an environmental product declaration. A lot of the different authorities having jurisdictions have policies where they're encouraging low carbon design and construction. For example, the Federal Highway Administration or the Department of Transportation for Illinois is now going to be developing an EPD purchasing program. The state of Colorado already has a law around that. I mentioned the buy clean requirements out of the state of California for things like concrete, steel, mineral wool board insulation. These are incredible ways that they are starting to do requirements. Cal Green out of the state of California, the city of and state of New York, Massachusetts, Austin, Texas, Dallas, Texas has requirements in their green building code. Up in Canada, don't want to leave Wendy out. There are a number of requirements, and the Canadian government is really focused on getting to net zero in the coming years. And this is just the North American area. There is a larger, if you go to the Carbon Leadership Forum, they have a really good area of this map that shows the rest of the world. And there are more and more of those growing around the world that have low carbon requirements, or at least tell us about your environmental impact when we're purchasing your product. That is a heck of a lot of information in 57 minutes. Wendy, do we have any other questions that I can answer as we go?
It doesn't look like we have any other questions, but yeah, I'll just give another reminder to folks, we have a little bit more time. If you do have any questions, feel free to put them in the chat. Otherwise, yes, I will make sure that any questions that come in after the fact will make their way to Josh. So, don't be worried about reaching out. If you do wake up at 2 a.m. this morning or tomorrow morning and go, hey, I didn't ask this question about EPDs and I'm curious about how to track this product, please reach out to us and we'll make sure that your question gets answered.
Dear Lord, Wendy, if people are waking up at 2 a.m. thinking about me, we've got bigger problems. God help us all. I hope none of you. If it's that big of a deal, please shoot an email to me right now. So you aren't woken up at 2 a.m. Let's get it out of your brain right now. Shoot me an email. Shoot Wendy an email at info@supplychainschool.com. Shoot me an email, Josh at wapsustainability.com. So you don't have to wake up at 2 in the morning thinking
Let's
about EPA.
let's avoid that if we can, absolutely. But know that we're always here for to support you if you do have any questions about sustainability. Thanks again for everyone for joining. I hope you have a great rest of your day and a great weekend. And again, stay safe if you're anywhere in the path of this snowstorm. Please do keep an eye out for my email. And we hope to see you at the next session. So I'll close by saying thank you, Josh. Wonderful presentation. Always fascinating to hear you speak. So thank you to everybody, and we'll see you at the next session.
Thanks, everybody.